Now, I remember the first class, I told you to run this code. I told you to run this code for us to, work on Spark. So I will run the code one after the other. I think I saw a few comments on WhatsApp. So I think some people they were getting um they were getting errors or whatever. And somebody was, I think Koblo supported you guys on WhatsApp.
Sorry, sir. My side, I'm struggling to hear you, to be honest.
Is everyone hearing me?
Yes, audibly.
Yeah, audible. So
Yes,
please,
I can hear you very
yeah,
well.
please, I will advise just check your mic. Maybe you restart the computer.
Okay.
Yeah, please. Yeah, thank you. Now, so we have Spark. Let me just take you to Spark. But I think, I took you through this last time. We have Spark. So we're going to be covering Spark now. We've completed everything related to list, tuple, dictionary, sets. We work with data, real data, and I showed you how to read data, how to load data. I've shown you everything. I showed you how to transform data, appending. We use appending, we use splits, we use all sorts of things within Python library. So we cover pandas data frame for ETL. That's extracting, transforming, and loading data using what? Pandas data frame. So in this case, today we'll be starting with something called Spark data frame. Spark data frame is similar to Pandas data frame. You use it for ETL process. Um, I don't want to actually load you with much. I will try as much as possible to cover a lot today. If possible, maybe we'll round up today, and if not, we'll continue um after next week because we have a general class next week, which is the CV review. So we have a general class next week, which is CV review. And after next week, after next Saturday, then we'll continue. That should be the last class. So I will try as much as possible to cover more about this Spark data frame. If you see, I shared the screen. I shared my screen. You can see Spark underscore Apache underscore org. So here, this is where you can get information about Spark data frame. If you see here, you see Unified Engine for Large Scale Data Analytics. Spark data frame, just like your Pandas data frame, you can use it for machine learning, you use it for data engineering, you use it for data analysis. You can work with it as a machine learning engineer, data analyst, data scientist. You know, you could use it for anything. Same thing is applicable to Pandas data frame. But what makes the two different from each other? Pandas data frame mostly deal with not heavily large amount of data sets, but Spark data frame can handle very large amount of data sets. For example, see yourself working in like in Facebook. Let's say you're working in Facebook, you're working with Google, you're working with some of these multinational companies like Shell, you're working in Chevron, or maybe some other organizations like that requires them loading or keeping the record of billions or millions of customers. That was why I mentioned like I said Tesla, um, Facebook, Instagram, Twitter, that's X. You know, you expect that as a data engineer, you'll be dealing with large amount of data set. I can bet it with you, they use big data tool called is either Apache Spark, they use Hive, or they use other, programming language. to do their data transformation. And because they deal with large amount of data sets, they won't be using some programming language that will not be able to last for long or withstand, should I say, that will cause their system to slow down, or that will reduce the performance of the application they are using in that organization. So they would rather go for something like Spark to handle petabytes, terabytes of data sets they are dealing with. And that's where Apache Spark comes in. Something very good about Apache Spark, most organizations now are trying to, do their data engineering work in Spark rather than in Pandas. Not all of them, but most organizations now, they are moving from Apache from Pandas data frame for ETL process to Spark data frame. One good thing about Spark data frame is that you can use different languages there. You can use R, you can use it with R, you can use it with Java, you can use it with SQL, you can use it with Python. Can you see? So it's a very, very powerful engine. So Apache Spark is a multi-language engine for executing data engineering. Can you see data science, machine learning on single node machines or cluster? So it's very, very powerful. So if you're a data analyst, you'll be using, using Apache Spark for processing large amount of data sets. Can you see I mentioned Python, like the Python that we've used? You could use Python in this environment, just like we doing slicing, list, tuple, dictionary. You apply within Spark, Python with Spark, Apache Spark. SQL that you've covered with Uncle Yinka. So you see how everything is interwoven now. So I've been on a project where I was dealing with Spark and I had to use SQL query. So the SQL query within Apache Spark helps to actually read or query very large amount of data sets without affecting the application. Without reducing the performance. In fact, it's going to improve the performance, because imagine you are using normal SQL and using Spark SQL to process data. So it's more faster using Spark SQL. It's still the same SQL language, but it's more faster to use that to do transformation of your data or query your data, depending on what you want to use it for. We have Scala. Scala, if you have experience with Scala, it's still similar to Spark. You see they are a bit similar. So Scala is good. Java, if you have experience with Java, you could maybe use that experience combined with the Apache Spark and, scale up in data engineering field. Now, here you see a lot of information in ecosystem. Apache Spark integrate with your favorite framework, for example, Pandas. Within Apache Spark, you could use Pandas data frame. You can convert from Pandas data frame to Spark data frame. You can convert from Spark data frame to Spark SQL. So you could use NumPy, all those libraries within, Apache Spark. Is a very, very, very powerful tool. Very, very good. So you deal with different file format, like for example, package format. You could maybe, write your file in package, read package file. It works with Apache Kafka. Kafka is for Internet of Things when you are doing streaming. Let's say you are working in an organization where they stream data from weather forecast in real time. For example, you see forecast data now. You can check online the temperature that we're going to have in the next. So they use all these to Apache Kafka to to do streaming of data. So we have other tools, Apache Airflow, Elasticsearch, SQL Server that you're all familiar with, Cassandra. We have other to Apache Kubernetes. This is also a very common, popular stuff now is being used. Spark SQL. Like I said, just try and get yourself familiar with Spark SQL. Everything we've covered, I think you are spot on to develop yourself in data engineering space. I can bet it with you. You've really gained a lot, but you wouldn't know now. But I can assure you that you've gained a lot. And so we're going to start here. So I've explained a few things. Last time I said you should run this code. Now I've tried to do that here. I'm going to zip the file. Zip is this. This is zipping the file SF Spark. This is the file part here. Zipping it from TGS format. So it's going to strip it from off from that file. Then let's do pip install find Spark. Then we want to store this environment, this Java home. We can check it here, and you see the content. We have content here. We have content. Can you see content? We have Spark. So it's downloaded here now. So everything is stored here. So we have user lib. Let's see if you have that one. JVM. Can you see JVM Java? Java 8 open. Can you see it's stored here? So everything we've been able to do that here from this environment and by running this. So we have import find Spark dot init this, then we'll be able to find the location of this Spark. So it's pointing that out for us. If you want to load file from any environment from your computer, you can use this to do that other way. Otherwise, you could maybe go here, just go here and upload file from the environment I showed you last time. Now, the first thing we need to do after running, going through the steps that we have here is to run from PySpark.sql import Spark section. So what we're trying to do here is that from this PySpark here, we want to access in SQL folder library, we want to access Spark section. I will open it for you now. Let's see where we have it. Here we have content, right? So it's going to be under contents. Our Spark is under contents. And when we open this, let's see what we have. Can you see? So we go to 1 second. Okay. From PySpark, can you see? PySpark, SQL. Inside SQL, you have what? Spark section. Does that make sense? So it should be under this section, section.py. So see, all what this line is doing is checking what we have here. From PySpark here, inside Python, PySpark here, .sql, SQL. Can you see is a folder under PySpark, right? From PySpark.sql, under SQL, we have another folder part called on which we can import Spark section from there, and you can get it from section here. If we open this library now, let me download it or open it. Let me download it and say keep record, keep. Okay, so let me open this file. You will see the section, Spark section. Is a program. You see, please don't get confused with this. I'm just trying to tell you what is happening when you see from this. So this is a Spark section. This is a different file entirely where you can access Spark section. And we are using this code to do our, can you see all Spark section? Spark section is coming from somewhere. Can you see? We have Spark section. I don't want to make it complicated, but I also want to make sure that I carry you along. So let's see if we ask, can you see return Spark section, the create data frame. So this whole code is a code, a function on its own that we are using. Can you see the Spark section is a class? Spark section, class, Spark section. So this is another level of Python. This is a Python code entirely. Please don't be scared. Forget about this one. It's not you. You don't need to really get scared about this. So we are loading Spark section from this library. From this library, this section.py file. So from PySpark.sql import Spark section. So we're getting that Spark section class. So if you check this Spark section now, you will see it's a class, a type class. Let's try it. Oh, it's not giving it, but it's a class. So it's not giving it in this case. No. Okay, so it's type class actually. So if I from what I showed you, there is a class. So now let's go on. So you are going to access this one now. So under this section, you have something called builder.appname. Builder.appname. So we have section.builder.appname. So from here, SOM15, so I can decide to write SOM18 in our case. So inside Spark section, you access builder. Inside builder, you have app name. Tell me 1 second again. I don't think I should. You need this, but I just feel like maybe showing you. 1 second. Okay. Let's see. Can you see the builder? Can you see the builder here? Does that make sense now? So it's a class. Builder under this. So we've got lots of code here. Can you see if raise? You remember the exception? This is just a typical example of that. But don't be scared about this. .app name. Can you see the app name? So we're accessing this file from the code. That you see that small line. Oops. That small line you see here. This is the code behind it. Does that make sense? App name. Can you see? Builder app name. Under builder, we have app name. And we can access get or create. If we check this further, you see enable Hive. Get or create. Can you see the get or create function? So that big code is the one helping us to do just one line. Can you see software development is very complex? So, but we as a data engineer, we don't need to actually go in depth into that. But I want to give you clue of what is actually happening behind the scene. So behind the scene, we have massive code somewhere in class, and we're just trying to load it and we are running our code. Does that make sense? The same thing is applicable to, when we are doing append. Append is just like that. So there's a code somewhere that we're just using from the library. And that's why we're importing this library module from PySpark.sql import Spark section from that module, from that library. Now let's go to the next line. So we are now doing Spark. We want to load our Spark now. Spark equals to Spark section. We're interested in using the builder.app name. Then we use this name SOM class 18 get or create. It's successful. So from here, we can, we can start, doing stuff. Let me see if I can do. Okay, so it's telling us, giving us information here now. It's saying initialize Spark context this. So we get it. Spark section is used to create class. Can you see data frame class? So it's giving, can you execute SQL over tables? Can you see catch tables? Read packet file. To create a class, we're using class one Spark section. I told you about class Spark section the other time. From here, you'll be able to get more information of about what is happening behind the scene. Can you see that I showed you the other time? So you have few information here. Some of the things you can use: localhost, app name. We use our app name here. You can set config. config helps you to prevent any form of error, but in this case, we are not using it. So then we have set, get, or create. So that's how it works. Now, for our data frame, I've been talking about Spark. We have something called Spark data frame. We have something called Spark RDD. We have Spark datasets. In this case now, we're using Spark data frame. So a data frame is a distributed collection of data organized into named columns. So it's in form of columns. So data frame is constructed from different sources such as a structured data file. Structured data file is a file that we've cleansed the data, we've done transformation on the data, just like the one that we covered while we were doing Python. Where we are doing data transformation, reading through folder path. Tables in Hive, external databases, or an existing RDD. So, I mentioned RDD. We have data set, we have RDD, we have data frame. So data frame is being used massively now. And how do you create data frame? So we're going to start with this. Already we know how to run our Spark. How do we create data frame? Let's say we want to create list. You are already familiar with list, so I don't need to be explaining this. We are creating a list called with a column name LA_code middle age. Remember this file? I used this file while we are doing data transformation at a point. So now I use this same name, and now we have a elements as the column names. So now let's go on. So I'm going to create here. I'm going to create. What do you notice here? Can someone tell me?
We have different data types. Like we have string, float. Yeah.
That's brilliant.
Yeah.
In this case, what do you see about it? I'm using close and open brackets. What does it represent?
Is it,
They're
is it
all
key
inside
and
a
value?
list. No, they're all inside a list.
What kind of, I talked about lists, I talked about tuples, I talked about sets, I talked about dictionary. What
Yeah,
does this look
yeah.
like?
Yeah, we have like
This is a tuple.
yeah, we have a tuple. We have
Yes,
tuples inside a list.
exactly. Thank you. We have tuple inside the list. You see how they are combined together. So now we have this. If we run this one now, we now want to add, we want to make sure that we're creating a file here now. In this case, we're creating this file. So what we are trying to do is that we're creating a file. Let me show you an example. Seconds. SOM data. Yeah, let me use this one as an example. We are creating a file without an header. Without header, right? Without header. Without a header. Let me delete this. Without a header. That is what is happening in this case. So we are creating a file. This all together. So we are doing it this way. We're trying to say we have a file like this. Okay, let me reduce the size. Now you understand what I'm trying to say now. Can you see? So we're creating a file like this. That's what's happening there. Does that make sense? So we're creating a file, tuple. We are wrapping it up like this. And we go to the next row, right? We go to the next row. We copy this again. and we're wrapping it up with a list. So I'm going to copy this again. Remember, this is, then I'm going to do this again. So something like this, something similar. Then we are what? Wrapping it up. And we're putting comma, 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 comma. Can you see? And we're putting it as a list. That's what is happening in this case. Does that make sense now? Because I try to relate it with what we have here. So it's like we have multiple of that here now. That is what you have here.
That thing is so awesome.
Sorry, if you know that, please try and mute yourself while we are trying to deliver. Now let's go on. So can you see the example? So I've shown you an example of what we have here. So this is like the first row, second row, and third row. In this case, I've shown you first row, second row, and third row. And if we compare it to what I just showed you, first row, right? And second row. Can you see? So it's similar. That is no different. That's the best way to explain.
No column name.
Column name. Yeah, you can put a column name, but I'm just trying to explain. I think you understand what I just did. So yeah, I can just put the same column name here, right? Does that make sense? So there's no difference between them.
Yes.
But in this case, we only have more columns. In this case, we have 2 columns. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns. So now, so that's how it works. So this is an example of you have a tuple and we have a list around it. Tuple in a list. Now, if we run this now, we've captured that part of the table without column names. So now, if I run this, now if I run that, let's see what's going to happen. RDD, let's run that. So RDD dots, see if connect is going to. Okay, can you see? It's printing that for us. But please don't be confused. I'm going to explain this one after the other. I know it's something new to you, and I don't want to make it a bit complex. So now, if you look at this, we've added. So in this Spark, we can access Spark Contest, parallelize. Then we can actually pass in our data, the real data, without column. Like I explained, I deleted the column here, so it's similar. You pass in the data, you run your RDD, and you can actually collect the value. But in this case, we want to now ensure that we capture the column. This is the data now. So the difference between RDD and data frame is mostly RDD. Most of the data you don't see any doesn't deal with the column. It deals with rows. It goes through the rows one after the other. Row 1, row 2, row 3, just like you see here. Row 1, row 2, row 3, without column header, without header at all. So
What
now
does the RDD stand for?
that's resilient distributed data set. So RDD here is can you see? Resilient distributed what? Data set. That's what it stands for. So, like I said, it's also Spark, but we have Spark in RDD, we have in dataset, and we have in what? Data frame. So we are using RDD, we're combining RDD now. And now we want to convert this RDD to data frame. And we're using a function called toDF. It's a function like I showed you the other time in that Python script, toDF, and we are passing in this column, LA and LA underscore code and midway. So because we have rows without column, without header. So we're adding the header to it. Header to LA underscore code to E0109 as LA underscore code and 2105 as what middle age. So if we run this now and we now apply in Spark data frame, when you want to show your results, you could use print, good. You wrap print around, but you use majorly show. You use what? Show. So if I run show now, we'll be able to see our result. Can you see? Now we've been able to pass in a column name, LA underscore code to that data and middle age, which is equivalent to y this. LA underscore code, LA underscore name. Does that make sense now? Does that make sense?
Yes.
Brilliant. So can you see I'm taking you back to this file and I'm telling you, what I actually did here. So I added LA underscore code as the header. That's the schema. I call it schema. Another name for header is schema. In Spark data frame, you call it schema. Now, for you to print the result, just like you use printdf, you use what? Show. But in some environments, it's necessary you use print with show. It depends on what you're doing. Depends on what you're doing. You use print with show to show your result. But in your code, it's not necessary you use code show. Just to make sure that you don't make things difficult in terms of performance. But it helps you to debug errors, to know what is actually happening within the code and know how and understand how to fix it. So now, in order for you to check the data type and your header or the schema of your data, you use something called print schema. Can you see? Print schema. Let's run our print schema. And from here, we could see, as we can see, that our print schema is what? Is data type string. And middle age is what? Double. And double is similar to when you are using integer, but the only thing that makes it different is that in Spark data frame, you have different data types. You have something called long, you have integer, you have float. So this is equivalent to your float. So in this case, you could use floats. It could be float. You could convert this one to floats. But in this case, you cannot convert to float because it's a combination of what? Alphabet and numbers, which makes it to be what? A string. Does that make sense?
Yes.
Thank you. If you have a question, please take me back before we go further. Any questions so far?
But this one that you call double, like middle age elements, they're like floats. But you said it's not the same thing as floats. Like this could be converted to floats.
Yes, thank you. It's the same thing as float, but the one good thing about Spark data frame is that it will tell you the data type that this thing is coming. In fact, sometimes you will read the data and it will come as a string. Why this is not a string? And you know the reason? Because you don't know the actual format of the source file. So the best thing to do is that first do print schema. Understand the format of your file. Understand the format of your file. Understand what is coming. This one is coming as string. This one is double. So if you prefer, in this case, you can do multiplication. You can perform any mathematical or calculation using double, float, integer. But this one cannot be integer because of what? The dots, right? So double is still equivalent to what? Floats. Does that make sense?
That means double and float are the same.
They are the same.
Okay.
They are the same, but it doesn't mean because they are the same. So in this case now, in case this one comes as, if it comes as as string, you could use a float and convert it to float. Does that make sense?
Okay.
Or you can use double, whatever.
Okay.
The major thing is you understanding your source file, the file. You need to understand what you are dealing with. What am I going to do here? Oh, we have this data as this. Oh, this is string. This has got this. How do I transform it? You remember the logical reasoning aspect. So it's very, very important when you are dealing with data. So it doesn't mean because you are seeing this data like this, other data will come like that. Does that make sense? Other other data will not come like that. They will come different, in different ways, like something completely different. So you have to understand how you approach the data, how you will deal with the data. So the approach is very, very, very important. So in this case, I'm just dealing with very simple data. Now, let's go on. We have Now, I've shown you an example of doing that. I said for you to convert RDD to Spark data frame, I showed you this RDD with no header, right? And I pass in header, columns, and what did I do? And I showed you result. And I printed schema here. And now you can also approach this particular data in another way. You create data frame from RDD with column names. So you could say, as you can do Spark dots, the Spark that we have here, don't forget, so that you can refer back to this. Spark dot create data frame. You pass in your RDD here, dot to data frame, and you put asterisk columns. Asterisk means capture all columns, because if I don't use this asterisk here, it will only capture only one column. And we can try it. Can you just give me error? But if I put the asterisk, if I return the asterisk back, it means capture all the columns and we are okay. And if I run this one out, so I've been able to convert data frame from RDD and I will get the same result. So in this case, I'm using create data frame to DF combined together. In this case, I'm using RDD to DF and create data frame. Two ways to create data frame from RDD is using create data frame or to DF. The same to DF, you could use it to transform from pandas data frame to Spark data frame. So it works fine. Let's go to the next line. So we can print our schema and we can see there. Another way is, we can pass in our the variable name where we have tuple in a list. We pass in directly to df and we just pass in the column and we get our results. And we can show, and we can print our schema. Create data frame is a function I showed you the other time. Pass in the data value, then dot to df column. Data value is what we have here. We created here, don't forget. Where is it again? Data value and what? And columns. We are passing it in here.
Okay, that means we are substituting data value for RDD.
Thank you. So we're passing it to just like RDD. You remember it's just row base. So we are passing the header inside here. Does that make sense?
Okay. Yeah.
So now I will show it. We have our results and we can print schema and that's it. So that's the first stage. And now we have libraries that we need to have access to. Like I said the other time, from PySpark.sql.types, import struct type. If you check here from PySpark, where is the Python? PySpark.sql.type, we should have type here if I'm correct. From SQL. Maybe type is somewhere here. Can you see types? Does that make sense now? Import struct type. So you're importing struct type. If we check here, you will see struct type there. Can you see struct type? Can you see struct type as a class? This struct field as a type. Can you see the struct type now? Struct type as what? A class. So we have a function. So this is a class on its own doing that job for us. You see, lots of things going on. You see, if not all those code that we've been writing, they are all here. So we've got lots of codes doing this job for us. So you can see struct type, but you see the struct field that you saw there. So string type, so they are all, they are class there. So now we run it. Then let's say we are creating another data value, just like I showed you the other time here. Yes. So we are running this one just like the other file. And if we run it, there is no column here. If you see, this is equivalent to we are having a file without header. I will delete the header again. So this is equivalent to me running this file. I think it makes sense if I do it this way. Let me create a new sales file. I want to try and explain in a simpler way as much as possible so that you understand what's happening. So this is equivalent to me, okay. Okay, okay, let's do it this way. Okay. So it's equivalent to writing E0 109 210 and low. Then we go to the next line, E1 208 890 and high. Then we go down, we have D1 009 1622 1622 middle. Oh. Can you see? There's no difference between the two. This is equivalent, is the same as this. Oh, sorry, give me one. So it's equivalent to this. So what we now want to do is that we are assuming that, let's say, for example, a stakeholder provides us this data. And they say, oh, Tony, Adaize, please, could you please help us to remodify this data and add like a column to the data and help us to save it so that we'll be able to know, if you send this file like this, it doesn't look fine. We need to assign a column name to this data and assign the right data type to this data. And you see the data is like this in this form, data value. Let's call it data value. So, but we now need to add a column to it. We want to add a column called LA underscore code. Let me expand it. LA underscore code. They want to add another column called middle age and level. Middle age. And I want to assign another column called level. That is what we're trying to do here. So if you see here, I said create schema using struct type, struct feed, and I'm assigning the right data type, string. In this case, if you see, is a combination of what? Is a combination of what?
Alphabet and number.
And number. So in this case, so that means we have to count it as a string. So we go to the next one. Middle age is what? It looks like what? An integer, right? So we use integer type. If you think that the data could come as a float, you could maybe just do this one as what? Floats. Does that make sense? Float type. Does that make sense now? Float type. So you could use float type because you're trying to think that this data could be float. So let me capture. Even if it's an integer, it will convert it to float in as much as a number. So let's go to the next one. Oh, this is string. Then I'll convert it to string. And I will now use my function here, struct type and struct feed. I'll do struct feed, LA underscore code, comma, I'll pass in the string type in string, make it true. Struct feed again, middle age, float type, true. Struct feed again, the level, that's the name of the column that we are adding. String type, that's a string, is true. Then when we run it, and we pass this one in, then we now use spark.create. You remember I said how to create data frame, you use to df or create data frame. So here we're using spark.create data frame. What's the data value? Our data value is this. And what's our schema? Our schema is this. Then we pass in our schema. And when we run it, oops. Let's see what is happening. Let me see. Saying float type. Can you see say integer cannot accept? Okay, it's type int. So let's do integer. Can you see I'm figuring out things now? Integer type. Let's see. Okay, let's see. It's gone through. Can you see? Because it says, let me return it back. Okay, if I run this one now, it's giving me error. It says cannot accept object in type, float type. So which one is float type? Is what? Is it not middle age? It says cannot accept object 210 as because it's integer. So I have to return my conversion data type to what? Integer. I'm using integer type instead of what? Float type. So you just figure out things. Now it's integer because everything is in integer. So let me run this one now. Then we are perfect. And I can show my data frame. Can you see? Is it different from what we have here? LA code, middle age, and level. Does that make sense now?
Yes.
Middle age, sorry. I think I missed something. I combined the names together. Middle age. So it's the same as this. So there's no different. So what we did here was we just tried to pass in a column name, the header or schema. We added a schema to that data because the data did not come with a schema. That's the idea about that. So we are printing the schema. Let's print the schema. Can you see? Because we assign string is string, right? We assign string here is string. Because we say is an integer is now coming as integer, right? And because you said it's a string, level is a string, is coming as a string. That's it. Any question? Question. Any questions so far? It's difficult, right? I will assume that we all know it now, but nobody is asking question.
We need to comprehend it.
We have to read it first.
No, it's not about reading. I'm talking about. Are you confused at any point, or do you want me to go back now and resolve it? Then we continue from there. I don't want a situation where I'll be talking and you get stuck. So it's better I take my time to explain and you understand clearly. Then I will give you assignment, because I'm going to give you assignment.
Let's go over it again.
From where? Where should I start from? Okay. I will explain this way. When you want to create data frame, you use 2DF or create data frame. Already you are familiar with this. When you want to create data frame, you use what? 2DF. Can you see? How did it to do 2DF? Or you use create data frame. 2DF or you create data frame. And when you're using 2DF, you could pass columns to it. So pass column to it, columns, and just print it out. In this case, we've used RDD to capture the value, right? Because I told you RDD is in rows. It won't capture the header, and from there, you're able to pick the value, and you pass in RDD to DF, passing the columns, the header, like the schema. In our case here, I created schema without assigning a data type.
Sorry, 1 second. On that command in line 28,
Yeah.
you put columns in bracket without the asterisk. Is it because it's one column that is why you didn't put the asterisk, which shares,
No,
yeah,
no.
gone.
Okay, I put column because we've already converted this to RDD. If you see, we've passed in this data value to RDD, and we've captured it, and I'm using to data frame, which is to DF. I pass in column directly. The other one here, I'm using create data frame because I'm using create data frame. You see, this and this they are similar, right? If you see, look at it very well. But the only thing is that in this case, I'm using to DF, so I didn't use asterisk. But in this case, because I'm using create data frame, it requires me to pass in asterisk.
Okay.
Because here, I'm converting RDD here to data frame before passing the columns, and it requires me to assign asterisk. But in this case, I have RDD. I'm converting this column to data frame, and I'm connecting it to this to passing the column. So because it's like here, I'm converting it back to create data frame, which looks like a long process, right? If you look at it. What if, because in this case, you see create data frame, here is RDD to DF. So you don't need asterisk. But because you are converting this back to create data frame, that's data frame, Spark data frame, not RDD, you need to pass in this. And let's check the other one. Can you see? In this case also, did you see that I passed it in? Because I use create data frame. Even despite I'm capturing this directly. So I converted to RDD, but it's not necessary. You see, this one and this one are the same.
this create data frame, can you, instead of writing it in full, can you say create df?
No, no, not at all. You must not try it. This is how it is. Just leave it that way because you are importing it from Spark.
Okay.
Yeah, you importing it from Spark. So you can't shorten it. You can't reduce it. You can't abbreviate or whatever. No. A variable name is something you can play around with, like this Spark name now. This Spark, you could maybe change it from here and put, what's your name? Sorry.
Lazarus?
Lazarus.
Yes.
Now I can put Lazarus here and it will still work. I can use Spark Lazarus and go here and do Spark Lazarus because a variable name, it will still have access to that function and it will still work all through. So any other place, I can have Spark Lazarus and run it. Oops. Okay. Okay, so I think it's asking question out somewhere. So Spark Lazarus. So I can do Spark Lazarus. What did I have here? 1 second. Okay, so I can do Spark Lazarus here to still work. So Spark Lazarus here, any other place, Spark Lazarus. Can do Spark Lazarus here. Any other place again. So if I run this code, it will still work as Spark Lazarus. Let me run this. So that's the only thing you can change. Any other parts, I don't think you can change. You can change the variable name, but you can't change the function, how it's being written. So that's taking time. I think that's taking time. Let me just, okay, it's done. Okay, so that's will be. Okay. Okay. Can you see it worked, right? Can you see the Spark Lazarus worked?
Yes.
So it doesn't make difference. It's going to work because we just pass in the variable name. You don't have to mention variable name. From here, we just use variable names. Spark, this is the main function. We pass it in, and we'll be able to access wherever we have within that, our stuff. So now, that is that. Please read. Please go beyond this. Like I said, read. So I've done this. I've shown you an example. And we've been able to print that. So now, so that's that for you. Now, let's go to reading file. Already, you've seen, for you to read a file in Spark, before I continue this way, already you are familiar with this. Spark.read.csv. But we've changed this one to Spark Lazarus, right? You remember? Oh, sorry, Spark underscore Lazarus. So it will not work. Lazarus. Spark.lazarus.read. So let's say we have a JSON format. We pass in. Now if it contains header, we pass in. Then we pass in the file name. So let's say this is the file name. So we can do this. So we can do Spark Lazarus.read.format What's the format of the file? JSON file. In this case, it's JSON file. What if it's CSV? What am I going to have here?
We'll
Remember,
replace JSON with CSV.
good. You see, this is the file name, right? .json. That's why we have it JSON. If this is .csv, then the format will be what? CSV. CSV. If this file is .parquet file, .parquet file, this one will be what? Parquet file. Does that make sense? So when you are reading the file, you need to specify the format of the file so that you'll be able to read it successfully. In this case, it's not going to work because we don't have a file, right? We don't have any file. But we can read the file. We can read the file. Let's say, let's import our file now. We've been playing around with which file again? Let's read a file. Import file. I think I have quick access file here. Good. So let's see. So we have a file. What's our file name now? Okay, let's see our file. So I'm gonna do that. Okay. Because I opened this. Okay, you're good. Oh, can you see our file now? Let me copy the file paths. Copy path. And let's see what we have. So I'm going to copy that file here now. This is the file path. If we run this one now, it's not a package file, right? It's not going to work. You know why?
It's a CSV file.
It's a CSV file. So let's see if it's going to work. Brilliant. Can you see? So now we're perfect. Yeah, we can use this one to, copy our file, but does not really matter. So from here now, we can now read our data frame. Let's read our data frame. df dot what? Show. I'm also using the file that you are familiar with. I send this file across. Can you see? Does that make sense now? So this is the file. It's including the header. It's going to include the header. If I say the header equals to false, what do you think will happen? Can someone tell me? Can someone tell me what will happen?
It will not show the header.
If it doesn't show the header, what is going to happen for that? Any other idea?
It will only show the rows, isn't it?
Okay, let's see. Well, I'm sure that is you're partially correct. Let's see. It's going to move this to another row. Let's see. Can you see? It's moving what? The column, the initial column to what? As a new row. Does that make sense? So now, there is something I also want to tell you. I want to mention something when we're doing for loop. You remember I was talking about if statements. When you are reading data, sometimes you like to maybe check if the data is not empty. You understand? You want to check if data is not empty. So most of the time you use something called counts. Can you see? Count is counting all the rows that we have in the data. Does that make sense? So here, let's say, for example, let's say somebody mistakenly deleted this file. Okay, now let's do if df.count is greater than 0, then print df dot show. Right? else. Else. File is empty. Can you see it's printing, right? So I now say else file is empty. Let's now do, let me play a trick. One second. Oops. One second. Just want to create a copy of the file. So df show file. Give me 1 second. Just want to create a duplicate of that file so that we can play around it. Okay. Mhm. So I'm going to delete everything that we have in this file, right? Let's do it now. Hmm. Okay. So I have data new, right? Okay, so our data new, oh, okay, on desktop. Let me do data new one. So we have data new one. And now I would like to import data new one now. Quick access data new one. So data new one is there, right? Now, look at this. We're able to get this right. Let's say, what if we pass in data new one here? Let's see what will happen. Don't forget we changed the file now. You see, we've changed the file. So our data new one now, this one has data, but this one does not. So let's play around this. And let's see our results. So it's got data, but let's use true. Okay. If header is true. Okay. What do we have? Okay, so it's saying print show data frame coming. Okay, so in this case, it's showing me that we have column, right? And that's what it's showing, but dot counts. Oops. It's 0. Remember we said it's df dot count if it's greater than 0. So can you see here, if df dot count is greater than 0, print this, right? But here, is it greater than 0? Is 0, right? So I expect, hmm, did I do something wrong here? Hmm. Okay. Oh, sorry. Look at me. Did you see that? I was wondering that. Oh, why did I? So I should have added print. You understand? Because you see what I'm trying to do here. If df is greater than 0, it should do df dot show, right? But otherwise, if it's less than 0, if it's equal to 0, it should say file is empty. Can you see file is empty? What I'm trying to do here is that in your data, sometimes a file will not be provided. So in case of this now, file is empty, what do? You break, right? So it's not going to be processed. So now you've been able to capture it directly. So in your data, you first check if data is there first, greater than 0. If you see, greater than 0 is checking row by row. It's checking the row, like I showed you the other time. It's checking here. Where is data 1? It's checking here. There is no data here, right? Row 1, row 2, row 3, row 4, row 5, row 6. It's checking everything. And if it sees there is 0, there is nothing to count. There is nothing to count. What will happen? Then don't do anything. Then if if there's nothing to count, print file is empty. So in this case, you are able to trace the error. You see how we're using if statements now. So we're even trying to check if the file is empty here using this. Does that make sense? Nobody's responding.
No, yeah.
Yeah, yeah.
It does.
Yes, so we're checking file is empty first before we start reading file. So here, you just do if df. When you are doing data engineering work and you're doing ETL, you will use this a lot. You know, I keep repeating this. Check if your df is greater than 0. If I change this one back now, let's change it to 1. You will see it's going to print show because it's now greater than. Now let's go on. Count. Can you see the count is 323 is greater than what? 0. If we run it, it's going to print show. Does that make sense?
Yeah.
This is capturing when there is data. If there is no data, print file is empty. I've uploaded 2 files, one with no data and one with data. The one with new one is no data, right? I want to make sure that we capture if there is no data. df.count 0. If I run this, if df.count is greater than 0, that means there is data. In this case, it's 0. What will happen? Print file empty. If there is data, if I change this one to the file, the original file, if I run it, it's going to give me 323. And if I run it, it's going to give me value because there is data. If there is data, print show. So if there is data, you can start doing other transformation and you start adding some other codes here. Does that make sense? So you'll be hiding your code, print schema, wherever within this file, print schema. And maybe do sort of, or maybe create columns, create additional columns, do multiplication. You do it within this code. Otherwise, it should what? It should tell you that file is empty. Does that make sense? So now that's how it works. So I'm trying to help you that in case you want to read a file, when you are reading a file, after you have read the file using spark.read, you have to check if the file is not empty. It's very, very important when you are writing your code. So let's go down. Can you see we are using the conditional statement you are familiar with? So there's nothing special about what I'm doing now. You're already familiar with it. Let's go further. What if I have a data with no column? What if I have a data with no column? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a data with no column. Now, let me go back to the other file. Our time is fast spent. So let me go back to the other file. UK data. Document. And I want to delete the column here, right? No column. There's no column in this case. I'm going to save it as documents. No column. Yeah, I think we're going to stop here. I think it's getting too much and people are not really picking up. So let's stop here. Then I will continue from next week. So what will happen is that I will stop here. Then I will give you an assignment to practice wherever we've covered. I'll try as much as possible to send the video across this evening again. So I'm going to stop now.